Good morning. Today we're going to start on lesson 2-4, and your warm-up looks a little bit different because this is pretty important to get things into slope-intercept form, because that's a real fast way to graph. And so as your warm-up today, I'd like for you to do these four. So pause your video, show your work getting it into, especially for 2, 3, and 4, getting it into slope-intercept form, and start your video when you're done. Alright, here's what I got. First of all, that's point slope form up there. We've been working with that for a long time now. And it's one of the fastest ways to get, if you ever slope and you're given a point, that's one of the fastest ways to get it into slope-intercept form is just 2 steps. And so over here on number 2, we just need to get that x to the other side there. And so we subtracted 2 x's from both sides, and hopefully you put it in slope-intercept form with the x's first and then the number without a variable last. This is important that you have it in this form because that's my y-intercept. If I was graphing that, I'd go down to -5, make a dot, up 2 over 1 this way because I see it's a negative slope. Draw my line. Over here, just a little bit bigger numbers, but still, you would have gotten that 9x to the other side. Start writing it in slope-intercept form and put the 12 last, 9x next. Get rid of that 3. And again, if I was graphing that guy, go to 4 on the y-axis, go up 3 over 1, or I could go down 3 and to the left 1, because that would be down 3, and to the left 1 would be a double negative, which is still a positive slope. And so, make sure you kind of think about that slope when you go to graphing, which we're going to do a lot of graphing today, okay? Alright, let's move forward to these things called parallel and perpendicular lines. In case you forgot, from a long time ago, parallel lines, most kids can get parallel. Parallel lines means it's the exact same distance in between them. And so when you draw your graphs today, I should see anywhere on that line that the distance between those two lines is exactly the same. Kids that don't have a ruler will have something very similar to this, where one end's really nice and tight and the other end's fatter. So you need a ruler. I want them to be just perfect, okay? We're in high school now, so we're heading that way. Perpendicular, spell perpendicular correctly. I tried to make that into an R, but that's a pretty cheesy R. Good night. It's going to be one of those. It's a Monday morning here. Perpendicular. Now, perpendicular means exactly 90 degrees. This is used in construction all the time. Exactly 90 degrees. Not 91, not 89. Exactly 90 degrees. And when we have a graph with a perpendicular line, it's a perfect 90, and usually we draw a little square in that corner telling the person that this is a perfect square. Okay? Big thing is, perfect square is 90 degrees. Straight line is 180 degrees. Used in geometry all the time. Alright, so let's see. Parallel lines, if it's parallel back on this guy, let's just say up here the slope here is an up 1 over 3. If it's up 1 over 3, well then my slope on this guy also has to be an up 1 over 3. So slopes on parallel lines, this is an easy one to remember, has to be the same. And so that's from last year as well. But now what we have is we have this equation, and they said, well, I want it parallel, but I needed to go through this coordinate called 8, 9. And so parallel lines have the same plane, they never intersect. Non-vertical lines that are parallel have the same slope, but different y-intercepts. And so what we're going to do is we're going to identify the slope of the given line. Well, they have it in slope-intercept form. So the slope is 3/4 of the current one. The new parallel line has to be the same. And so I think I got it right next here. Yeah. So we're going to use point slope form. We know the slope has to be a half. Pretty sure that's what it was up there. It's on your paper. Oh no, it's 3/4. Good thing we stopped and paused. The slope is 3/4 on the original line. So we're going to say 3/4 here. And they said it has to go through, boy, you guys got it nice, 8, 9. I want to write the coordinate here. So let's go. Y minus 9. By now you should kind of got the idea that we're doing the opposite signs of my y. We've been doing that for a long time now. X, and if I have an 8, it's a minus 8 here. Alright, go get it in the slope-intercept form. 2 steps. Let's do 3/4 times -8. 8 times 3, 24. 24 divided by 4 would be a minus 6. Get rid of that 9. Alright, so there's our new equation. Now we're going to check. I can't see that original equation up there. Alright, let's go graph the first guy there. He had a y-intercept of -2. His slope was up 3/4. 1, 2, 3, 1, 2, 3, 4. It was a positive slope. 1, 2, 3, 1, 2, 3, 4. And if I drew that line, it would be in a positive direction. Most kids, as I see their graphs, are doing a good job of making smaller dots here that they can see the intersecting points and putting arrows at both ends. Let's go to our new guy. He had a y-intercept of 3 right there, up 3, 1, 2, 3/4. And we could go down 3. Let's graph that guy. And this is what I'm talking about. The distance between my lines is pretty much the same all the way along these two lines. Now, they said I had to go through 8 and 9. Now, 6, 7, 8, boy, that'd be hard to tell, but 8 and 9 would kind of probably be up there somewhere. It's not on our graph paper, so it's kind of hard to tell if it would go through 8 and 9. But I can see that they're parallel, so that gives me hope. Okay, and I can kind of predict about where 8 and 9 is up there. Alright, so slopes are the same on parallel lines. Alright, try these two. It's going to take you a little while, so just pause your video. But do both of them, and you graph both lines on your graph. The original one and the new one. Now, before you go and pause here for a second, this really here has a +0 here. So that means the y-intercept is a 0. I have a negative slope, so when I'm done, my line should be going downward. Alright. Pause your video, get those 2 on there, really 4, because you have 2 math problems. Alright, let's see how you did. Purple line is my first one. And so at 0 I had a -2, so I went down 2/3. So there's my first line. Over here I kept the slope the same. I put a -5 for the y right there, +3 for that, because this is my x part, that's my y part of the coordinate. Did my math, and I got y equals -2/3 x plus 3. Put a dot on 3, go down 2/3. And look, my lines are perfectly parallel to each other. Sometimes we get really tight lines. It's okay. Here's my slope, it's a 4 originally. It's an upwards positive slope. Put that 4 in, put a 4 for the y, opposite signs, did all my math, and I got y equals 4x plus 0. So that means it goes through 0, 0. That's my y-intercept, up 4/1. I went down 4/1 to get my 3 dots on there, and drew my lines. Nice. Alright, now, so that's an easy rule to remember. Slopes are the same. Now, this is an easy rule. This looks very complex, but it's really not. Perpendiculars has this special rule. Let's look at this guy here for a second. If I was doing the slope of the blue line, I want to write blue here. And if, let's just say I went down this many, let's just say I went down 2, and I would say probably 3, 4, 5. I went over 5. So I went down 2/5. Let's just say that. Now if I rotated that guy 90 degrees like they're showing here, well the B is right here, so now I have go up 5, and so this is going to be my red line. I went up 5, but my 2 is now up here, so I went over 2. So now look, -2 over 5 was my original one. My new one at 90 degrees is 5 over 2. Now what they say is this has a product of -1. If I multiply these two fractions together, -2 times 5 is -10, and 5 times 2 is 10, which equals -1. If my slopes of the two lines multiply together to equal -1, then they are a perfect 90 degrees. Okay, that's a rule to remember, especially in geometry as you're coming up next year. All right, now here's the rule for when we're writing equations. Look, all they did is flipped it. The 5 goes on the top, 2 goes on the bottom, and they changed the sign. That was a negative, the new one's positive. So the rule for perpendicular lines on the slope is flip the fraction and change the sign. It's an easy rule to remember. Just take the slope, but first you got to find the slope, flip it, and change the sign. All right, let's go try a couple. They want to know if these guys are perpendicular, so let's go with line P. Okay, let's find the slope of that guy. It went down 1, 2, 3, 4. So it went down 4. Well, I should probably write slope. It's the slope for line P. So I'm going to put this down 4 over 1, 2, 3. Now let's go do the blue line. Blue. Find two good dots. Here's one. Oh, they gave us two dots. So that one's going up 1, 2, 3. And over 1, 2, 3, 4. Now if I multiply these guys, do they really equal 1? -4 times 3 is a -12. 3 times 4 is 12. It equals -1. So, yep, these guys are perpendicular. Let's go do these guys. Let's do P. It's a negative slope. 1, 2. He went down 5. And so we're right here. 1, 2, 3, 4. It's a -5 right there. Kind of looks, I want to rewrite it. -5/4. Digital ink is kind of a pain. All right, let's see at this guy from here to here. 1, 2, 3, 4. He went up 4 over 1, 2, 3. If we multiply these guys, I get -20 over 12. That doesn't equal -1, so these guys are not perpendicular. All right, and they kind of don't look perpendicular. Back over here, sometimes in geometry you'll see this often. You've already seen this, that they'll draw, if it is perpendicular, perfect 90 degrees, they put a little square in one of these right here. Okay, good symbol to know. It's perfect 90. All right, now, not always do we have graph paper, but we want something that is perpendicular. And they also, now in 9th grade, wanted to go through a certain coordinate. So I don't know if I have graph paper down below on this one, I can't remember or not. So we're going to use the slope of this guy. So this guy's already in slope-intercept form. So the slope of this guy is already a -1/4. And we want one that's perpendicular. So we're going to write -1/4 here. But if I want the reciprocal of that, nope, we want to flip it. Looks like they gave it to us up here. So we're going to flip it. So we're going to put the 4 on the top, the 1 on the bottom, and change the sign. It was a negative, now it's a positive. So we're going to use 4, or 4 over 1. That's the slope of the new line. Now they want it to go through 1, 7, so we're going to put those numbers in the right place. I'm just going to use 4. And there it is in point slope form using that place. And let's get it into slope intercept form. 2 steps, always. Now let's go see if they have some graph paper for us to check. They don't. Was that example 3? Is this a new problem? Yeah, it looks like it's a new problem. But this one we'll be able to graph here. Alright, so let's go do this. Here's my slope. It's 3 over 1. So I want to do it this way. Find the slope of the line. I usually do this. It's 3 over 1. And then I draw a little arrow here. My new slope has to be a 1 over 3 and change the sign. So we're going to write it in point slope form using these coordinates right here. Using the new slope. Oops, it's a minus 3. Alright, let's go to work. Negative times negative is a positive. So there it is. Write my equation in point slope intercept form. My new equation is y equals minus 1/3 x plus 3. Let's go graph these two guys. I like to do my original one in purple. I'll try to do that all the time. My y-intercept is -1. I have a positive slope, so my line for the first one should be going up. 1, 2, 3 over 1. 1, 2, 3 over 1. Draw your line. Let's go do our other one. This one has a y-intercept of 3, and my slope is down 1 over 3. Down 1, 1, 2, 3. 1, 1, 2, 3. And let's go draw that guy. Alright, arrows on both ends. Lines always extend all the way across the graph. That looks like a pretty darn good 90 degrees right there. Okay, they crisscross at a perfect 90 degrees. Alright, you got one. Go give that guy a shot. Pause your video and come back when you're done. Alright, let's see how you did. This one was kind of a little bit strange. It's way up there in the front top corner there. I always like to do this on the slopes. Find my slope. My original one is this, and when I'm going perpendicular, you flip it, change the sign is the rule. So then I use those coordinates. Let's see, 4, 5. Yep. Changed the sign when I put them in. Went to work. Got a +7. Now 7 was off, but it was only off by 1, so I can estimate pretty good. And so when I went down 1, I knew that would be back at 6 and over 2. So now I know where that dot is, and I went down 1 over 2 again. Now our 2 dots went down 1 over 2 again. So now I'm pretty confident, even though I estimated up here. So get them on there, and hopefully you did that one right. And that one looks pretty dang good at about 90 degrees. It's really kind of frustrating when a kid has a problem and when I'm looking at their graph, and their graph looks something like this. I mean, it's clearly not a 90-degree angle there. And so rather than going back and looking at their work, they just say, you know what, it's okay. Graphs are worth 2 points, because did you graph this line right and this one right? And then another 2 points for did you put the numbers in right, and did you get it in slope intercept form? So every one of these graphs is really worth 4 points. Did you get the slope right? Did you get it in the slope intercept form? And 2 points for your graph. So when you miss one graph, you're not missing just one question. You're missing 4 points. All right, this one gets a little confusing, but this is real world stuff, so here we go. This doesn't look like a perfect 90 degrees, so we just got to be careful here as I'm looking at this. This farmer decides to use part of her land to generate a solar energy, installing rows of solar panel on either perpendicular to Meadow Way. So here's Meadow Way. So he wants it to be perpendicular to that one and parallel to this one. Okay. And they said the panels start right here. Beginning of first row is at 4, 3. Well, that makes sense. There's 4, 3. What equation would you describe the two options of the row? So let's go find the slope of Meadow Way. I'm going to underline Meadow Way because they kind of did these a little bit backwards is the way I would look at this graph. Alright, so let's go find some good points on Meadow Way. Usually the y-intercept is a good one to look at. And most of the time it is a whole number, but not always. So I'm going to scan this line until I find another one. Looks like right there is one. So the coordinate's called 0, 1. I want to write it underneath because I noticed that you don't have enough room. 0, 1 is one of my coordinates, and that guy looks like he's at 5, 2. So let's go find the slope of that guy real quick. We need to know the slope of the original equation. So the slope is a positive 1/5. And I agree it's a positive slope. Let's go find it for Meadow Way. Or North Road, I guess it is. Up here at North Road, it looks like the y-intercept might be at 0, 11. And I'm going to scan that. Looks like a good dot right there. So 1, 2, 3, 4, down 4 over 1. Well, I already know the slope, down 4 over 1. So let's make sure we can get it. That would be a 1, 7. Let's just see what happens here. It better be a negative 4, 1 when I'm all done. Well, I got the 1 on the bottom. 7 take away 11. Yep, that's 4. Alright, so we got the slope. We could have just done it by looking at the graph. Alright, now let's see what they said. They want it Meadow Way, which is this guy. They want it parallel to this guy, Meadow Way. So parallel means I need the same slope. And I want to scroll down. It's 4, 3 they want us to go through. So I want to put 4, 3 here because this is Meadow Way. Yours is up top that you can see it easily. Our slope for that guy was 1/5. So let's go to work. I'm not going to make these into a decimal. I'm just going to leave them that way. I want to leave my slope as a fraction. Let's see what we get when I got negative 4/5. So, did I do something wrong here? Not getting the same answer I had on my paper, so I just want to check my work. Did I copy that problem down? Yeah, my x is a 4, 3. Alright, I think I'm doing pretty good here. Just doesn't match my answer on the paper here. Oh, you're screaming at me. Look, we want it perpendicular to Meadow Way. I can fix this easy. That's why it's not matching. I didn't read the question. I want to get rid of my slope. Because if the slope up there was, the original one was 1/5, my new slope has to be a negative 5 over 1 to be perpendicular. No wonder. Alright, I apologize for that. So it's easy one to fix because that's going to be a minus 5x. Now this is where I had a little bit of a difference that I just glanced over at my answer key. So negative 5 times 4 is a plus 20. So that's an easy one to fix. Sorry, I thought this was parallel. Perpendicular parallels down here. Alright, so now I got 20, 23 plus 23. Alright, let's see if that's what I got on my other paper. I got negative 5x. Oh man, this is all wrong here. Let's see, this is a minus 5x plus 23. I'm going to check my work here. Plus 20. Sorry, I got to fix this on my answer key here before I forget it. And so that makes it plus 23. I like plus 23. Alright, try to be more careful on this next guy. The next guy wants to be parallel. So for a slope for North Road up there was negative 4. And I want it parallel. I need my slope to be the same. But I want to still use that coordinate up there called 4, 3. So minus 3 goes there, minus 4 goes there. Let's go to work. I'll try to be more careful here. Okay, so I got minus 4x plus 19 on that guy. Alright, so pay attention to parallel and perpendicular. Okay, see I did it on my answer key the wrong way too. So I didn't do parallel, I did perpendicular. Alright, I'm pretty sure we're good on that one. Alright, you got one here to do, and then we got a practice sheet to do here. Alright, pause your video, try that one. You got to kind of look up their original slopes and make sure you pay attention to not only the road name, Meadowway, but they want it perpendicular. Okay? Alright. Go to work. Let's see if I did it right. Welcome back. I hope I did. The new slope for perpendicular has to be a minus 5, because up on top it was 1/5. So I like that. Put a 9 for the x, 4 for the y. I like all that. So I think I like that guy. Up there on the top, North Road was a negative 1/4. Uh-oh. I lied. Gotta fix this guy. They want a parallel. So I gotta do some fixing here. Alright, did it incorrectly. They want it parallel. So parallel means I don't want the new. It was a negative 4, so I'm going to keep it as a negative 4 times x. So it's going to be a minus 4x plus 36. And then I want to add 4 to both sides, so that'd be a plus 40. Alright, sorry about that one. I gotta read the directions. Parallel, slopes are the same. They've got North Road. I'm gonna go back up there. North Road slope. North Road slope was a negative 4. That would be correct. Alright, so made a boo-boo there. Gotta get it right. Alright, on today's, it's kind of like sometimes pretty quick and easy for you, I hope. That you look at this guy. This is a bad copy. Yours is hopefully a little bit better. My slope is right there, that it's a 1 or a 1 over 1. The point they want me to go through is negative 1, negative 1. Now we're going to put it in point slope form. So it's always a y plus, there's my y right there, opposite sign, equals 1 times x, opposite sign. And now what they want you to do is they want you to get it into slope intercept form. You could have y equals x or x plus 0, okay? We know there's a plus 0 there, and we also know there's a 1 in front of that, 1 over 1, so that'd be the simplest thing, okay? Now you're going to really kind of freak out when you see this down here. Yours graphs a little bit better, but every time I copy it, it's a little bit worse. And so what you have to do is you have to find the slope of this first guy here, which I can't even tell on mine, but you can see yours. It might be up a 1, 2, 3 over 1, I don't know. But your graph is a little bit better than mine. But it for sure is a positive. The coordinate they want you to go through is a -1. And then the final, now will you write graph? So after you get that, graph that guy. They already got the first one, but I need you to graph this guy and see if it really is parallel, okay? So use the graph paper on there, and that happens several times. I want these guys graphed on that same graph there, okay, to see if they are now perpendicular. So if you'll write graph on those guys, that would be great. Anytime they give you a graph, I want you to graph to prove it. Okay, so it looks like you got 20 math problems today, dude. All right, well with that, we'll see you tomorrow, I hope. Have a good day.